a couple of minutes of your time and do a very, very short introduction of Wagon community that I'm representing. For those who don't know, my name is Sasha. I'm in charge of community and events at Wagon Tokyo Coding Bootcamps. And right now I will share my screen to give you a very short presentation about us, what we do. Cool. I believe everyone can see my screen. What is Wagon? Wagon is a global coding bootcamp. And what we do here, we teach people how to code web applications from scratch during our web development bootcamps, and also how to use, analyze, manipulate data during our data science bootcamp. We do it in two formats. For those who want to dive into tech right now, immediately we provide a full-time bootcamp, 9 weeks, very intensive study from 9 to 7 p.m. every day. And also for those who have some work or family commitments, we offer part-time option, 24 weeks studying after work and on Saturdays. A bit stats that we proud to show off to the public. We are top ranked bootcamp worldwide, and we actually reached a very important milestone recently. We hit 10,000 graduates. So 10,000 people graduated from our bootcamps all over the world in 40 cities, including in many continents, including Asia, Europe, South America, North America. We also very product-oriented bootcamp. So 90% of the time our students are coding. And that is the reason why we have so many startups being born out of the Wagon bootcamps after the graduation. A bit stats about our local campus, Wagon Tokyo, where I'm working. We are based in Tokyo, 7 minutes walk from Meguro Station. I hope some of you who are in Japan might one day take a look, stop by our campus. We started in Japan 4 years ago. Since that time, we had around 300 graduates. And we have a very diverse nationalities. Usually now we're a bootcamp because we teach in English. Every time from 7 to 14 nationalities participate. The average age is 29 years old. That's the time when people decide to change their career. So far, we have 25% of the women. This is not something that I am personally proud of, but I'm really trying my best to make this number higher. And I hope that events like today will help us to reach the gender equality in tech in Japan. Cool. That's about the career path that usually our graduates take. A lot of them obviously want to find a job after the bootcamp, and those are examples of Japanese companies who hire them. Basically, a lot of startups and global companies. Various careers paths that our alumni take after graduation. A lot of them become developers, product managers. Some of them start their own ventures, and some of them decide to go freelance or recently to become data scientists. Those are just dates for the next bootcamps. If in case you're interested, feel free to reach out to me. And this is one of the most important events that we have, actually. It's called Demo Day. That's the time where our graduates present their web applications in front of the public. It's very cool, intensive, and interesting event for those who want to understand what's going on and how people actually can start coding after such a short period of time. So I strongly encourage you to join if you're interested in what we do. Cool. And that was all from my side about our community. Now I'm giving the microphone to Alice. Please, the stage is yours.
Thank you very much. So I have prepared a dedicated presentation to just guide us through the journey of the, let's say, discovery of the space industry and all the many aspects that I hope will be clear after these today's presentation. So thank you very much for inviting me and for giving me the chance of just sharing my experience, the one that I had up to now, with all of you. I really hope that this will be helpful and interesting. So, as you know, I am Alice Pellegrino, and I'm from Italy. In particular, I was born in Rome, and then I have studied there at Sapienza University of Rome for both my bachelor and master. The bachelor in aerospace engineering and the master in space and astronautical engineering, with the specialization in remote sensing from space. Through the university years, and also for my thesis project for bachelor and for master, I had the chance of just traveling a lot through Europe to attend different international conferences, also outside Europe. This is how I discovered also Japan, and to work in a couple of Italian companies, and also to have an internship at the Earth Observation ESA Center in Italy. And also to work in a Dutch company for my master thesis project, where I spent almost 1 year. So after graduation, I had the chance of getting a job in Japan, in Tokyo, for Canon Electronics. And I worked there up to the end of last year, and then I moved back to Europe. And then I got the chance to just have this job where I'm currently working for Kinetic Space in Antwerp, in Belgium. So I am currently working as a system engineer at subcontractor managers here in Kinetic on projects related to docking systems for bigger vehicles that work in space, like the International Space Station. While I was in Japan, I have worked as a lead system engineer on microsatellite projects. So imagine satellites that weight like a person, so around 60 kilograms, with onboard Canon cameras, so the EOS sensor that are commonly used for ground-based applications, but then onboard the satellite orbiting at 500 kilometers above our heads, shotting pictures of the Earth with a dedicated telescope developed by Canon Electronics for high-resolution pictures to be used in different kind of application. But the easiest one, it's imagine the pictures that gives the satellite view on Google Maps. So this is the easiest way for illustrate that kind of applications that it's within the Earth observation field. But I will go deeper on that later. Of course, in addition to my professional background and career, I also I've always loved traveling. I really enjoy my free time with friends. I'm quite, open and usually a lot talkative. So I love talking, I love share my ideas and meet new people. I love reading also, dancing salsa, and in my every time that I have the occasion, as also Sasha introduced, I try to cooperate and to support also from remote the Italian chapter of the Women in Aerospace Europe, that is called the Rome Local Group, and so I kept cooperating also while I was working from the Netherlands, while I was working from Japan, of course, with the time shift, but to support their activities in terms of networking, coaching, mentoring, and also research. That was dedicated to gender equality. And we created a dedicated subgroup within the organization that it has been doing research on this topic within the aerospace sector, the Italian but also the Japanese one, for at least 4 years that I'm the responsible of. So if you have any question later, maybe we can also discuss about that. But so given that today's event is dedicated to know a bit more about what space engineers do, I decided to just briefly and try to summarize some of the main information that can be very helpful for understanding a bit the space, but also the aerospace sector. And so at the end of this, I will just give you the chances of making questions, specific questions of this chapter, and the same is going to happen from the next ones. So let's just go inside that. When we talk about space, then usually the type of background that it's going to lead you to space pass through the aerospace sector. So, for example, in my case, aerospace engineering, it's a mixture of both the aeronautical and astronautical and space one. So, for example, in the first 3 years in which I have studied, but that's something that it's quite common before arriving to aeronautical and space. You usually learn a bit of both these aspects. So aeronautical, that it's mainly related with the atmosphere and everything that can fly within the atmosphere, even if the let's say the upper border of the flight's altitude, it's by standard kept at the course altitude, so around 10 kilometers for the planes. But then usually you cover all the different aspects, also in terms of what's which are all the basics and what's required also to reach up to that altitude, and also from the technical point of view, what type of vehicles can allow you to go that and how they work. And then, for example, in my case, during the master or within, let's say, the end of the bachelor, there is more the chance of discriminating between these two aspects. So it's a common that you acquire in the first years enough information for being able then to decide if you would be more interested in working in the aeronautical field and then in the astronautical and space one. And so, for example, then this is something that it's required for example, it has been required to me to decide to go in one or the other aspect. So, for example, in my case in Sapienza, we could decide to specialize in one or the other, while there are other universities all over the world, not only in Italy, that do not make this specific distinction. But in any case, then let's say that when it comes to space, the Kármán line, so 100 kilometers is the border that has been officially defined for the start of outer space, even if satellites start to remain, let's say, in orbit without descending to the Earth, and they can maintain for a longer period their orbital altitude after 300, let's say, kilometers. So depending on the topics, depending on the mission that a satellite has, or for example, even an interplanetary mission, then you change a trajectory and you change a type of orbits. So within the aerospace sector, there can be a lot of different aspects and type of applications. So a large variety of components, of spacecraft, of vehicles that, depending on the application, depending on the purpose of the mission in which they are going to be used, then they completely change aspect, design flow, information that you need to take care of, even with aeronautical vehicles. So depending on the environment in which a specific platform needs to operate, but this is also something that you have for ground-based application. Of course, you design a ship that needs to survive in the sea for different purposes in a completely different way of what you do for designing, for example, a house. So the same we have in space, of course, in its specific ways, and depending on the environment in which your vehicle needs to survive. So, for example, a new planet, Mars, so a rover that needs to survive autonomously on Mars, or a lander that needs to just pass through another planet atmosphere, or rockets that needs that need to lead your satellites or to bring our astronauts to the ISS, for example. So depending on the application, then a different process, different aspects shall be covered, from the designers, from who is testing all the hardware that is realized, even, for example, for the communication. So you need ground-based infrastructures to be able to communicate with satellites, and so them are going to require completely different type of design and details that you need to take care of. But let's say that one of the leading and shared aspects that all of these platforms have are the STEM fields. So of course, when it comes to the design, to technical aspects of them, a background in science, technology, engineering, mathematics is for sure something that can help, because then daily you need to deal with those aspects, with something that requires you to count or to just apply some physics theorem, or to just understand some piece of technology. So even to consider new and innovative technologies that can be applied to simplify problems that nowadays you have. But of course, then depending on your path, the way in which you arrived at the decision also to, for example, in this case, I imagine that if you're attending, you could be interested in just tackling and starting and discovering if it's possible to just change your path or your career. So it's not mandatory to have a STEM background. But of course, it's something that you have to put and to consider, because for sure you will deal with something related to STEM and to technical fields and technical aspects. Then, of course, within the aerospace, I'm saying this because we are talking about what does a space engineer do. Then, of course, the aerospace sector includes a lot of different other aspects, from the space law to the even space architecture, for example, to, I don't know, of course, business experts, then project management. So there are a lot of other also variety of roles that can be also part of the aerospace world. So just to clarify why I'm talking about STEM, but then of course a better knowledge of these kind of subjects are very, very a strong asset for boosting your career. But of course you don't need a bachelor or a master or a 2 years master on that. You can also go deeper on something specific, more technical, dedicated master, to just eventually being able to specialize on some of the aspects that you can be interested in. So when talking about space engineering, then you need to consider, I mean, everyone knows all the main aerospace agency, especially NASA, JAXA, ESA, but then usually every nation has its own agency, let's say, or at least an organization that put together all the interest of the different players that you have within every nation for what concern the aerospace sector. Then depending on the country, depending on the different approach, you have the academic field. And in this one, as I said, it shall not be aerospace engineering. Then of course it depends on what you prefer for you, but then depending on the academic system, then for example in US it's completely different. Then you can do a bachelor in a different subject and specialize at during the master or the PhD. That's more common. And even in, for example, in Italy, we had the same I have colleagues that with a completely different bachelor, for example, in physics or in other subjects, then they decided to do the master in space engineering, or to start going in some of these, for example, in Rome, we have a school of aerospace engineering that it's a 2 years course for who has not aerospace or mechanical background, but then it's offering also some specific courses also on on aerospace engineering. So it really depends. Then there are different, for example, there is the International Space University that's it's offering different types of courses for different interest that covers different aspects. Of course, it cannot go for 1 year, for example, cannot go deeper into some very, very technical aspect. But of course, for getting in touch with the aerospace sector, it's something very, very useful. So it really depends on what could be your interest for that. And then, of course, industries and private sectors at different levels. It's an aspect that for sure has a leading role, usually connected to agencies. For example, here in Europe, it's very common that private industries cooperate or work together, strictly together with the European Space Agency on different projects. But of course, then also autonomous development or specific type of businesses, depending on the type of companies and the related interest. And then another big field in which we can see, and we have seen all the main innovations used at first, is the defense one. So the first radar, the first GPS system, all the main let's say technologies that luckily with the time have been used also for other and public applications, started with defense and with the idea that some technology is useful also for this sense. Sorry, going in the wrong direction. So to just cover, let's say, in a more specific way, which could be the different applications that you have in the aerospace sector. Of course, these are only few of the ones that you can find, but let's say that these are covering the wider range of the ones that you can find. So as you all know, services like GPS and navigation or telecommunications could not work without satellites orbiting above our heads and communicating with the ground and exchanging data with the ground stations and antennas that you have on the ground. Then, of course, depending on the technology, you need a lot of the specific components, but for what concerns the satellites one, I will go a bit deeper later on that. In the latest years, smaller satellites started to become let's say slowly, big players in the aerospace domain. So for small satellites, I'm talking with satellites also up to 0.5 kilograms. So something that can be big as a cube, 10 by 10 centimeters, up to, for example, 150 kilograms or even more. When we distinguish between large and small satellites, it's a comparison, let's say, between 1,000 kilograms and 5 tons of satellites. So depending on the application, then it has been demonstrated that smaller satellites can cost less and can be useful. Of course, they have limitations, but they can be very, very useful for the applications and can allow saving a lot of money. And of course, related to these new small satellites, also smaller components have been developed, and a completely new market dedicated to the development of smaller components started. And then, of course, this is something that I already mentioned, Earth observation or observation in general, so that can be from the ground to the outer space. So, for example, the monitoring of space junk that we have in our orbits, or that are also called space debris, or just the relationship between astronomy and aerospace. and also, let's say, observation that can be done from space to the Earth, but from space to any other planet. So the entire topic related to remote sensing, it's not only focusing on the kind of pictures and data that you can acquire from space of the Earth, but also to all the type of data that can be acquired with different types of instruments of any planet's surface, also by relying on vehicles and platforms that are remotely controlled from the Earth and that can operate around an asteroid or another planet, as, for example, it happened with the Moon or with Mars. So of course, the Moon is not a planet, but you meant I think you understood what I meant. And then, of course, related to this type of pictures that we can get, or type of data that we can extract from the picture, there is an entire branch that's dedicated to data processing. So different level of data processing that's, for example, supporting research for different scientific applications, to understand and discriminate, for example, from space, different type of coverage, land surface coverage, or even, for example, for the weather forecasting or climate change research. And even, information taken from the GPS and navigation and GNSS signals that are within the atmosphere, are passing through the atmosphere, can be used also for all different aspects and research, scientific research that can be done, can allow us understanding more about our planet and how it's changing and evolving day by day. And last but of course, not least, interplanetary missions. So everything that it's used also for reaching the orbit. So launchers and propulsion system that can be also used for keeping, for example, a specific orbit, or keeping, let's say, propelling your spacecraft for reaching a very far away planet. So these are just, let's say, some of the aspects that you can find, some of the different applications and different platforms that you can work on, or different fields you can go deeper. And one day, without satellites, it would just be a lot difficult also for just using a GPS. If you are, for example, abroad on holidays and you lost the connection, or for example, the satellite of the GPS are not enough in visibility. So it's something that sometimes you don't think about, but then if you start tackling the topic, it's something that really demonstrates you how small is the gap from Earth and space, even if, of course, physically speaking and practically speaking, it seems so far away. As I mentioned, just going a bit deeper into, for example, which are the different subsystems that you can find and that allow spacecraft work. For example, for just keeping spacecraft or vehicles on their trajectories, or even for keeping them in a specific orbit. Depending on the altitude, you can also face some decay rate, depending on the type of environment that you select for your spacecraft. For example, for satellites that require to look at the Earth, for example, for Earth observation and acquire pictures with very high resolution, usually you need lower altitude, because of course you have a very good telescope and sensor on board, but then depending on the technology that you are using, some of the performances can be fixed. But then if you are closer, then you can get more details. So the space resolution that you can tackle is higher, and the lower is the orbit, the faster is the decay. So as I was telling you, 100 kilometers is not far away enough from the Earth for just remaining for a longer period in orbit. But then, for example, if you want to even go at 300 kilometers and not returning, of course, it depends on the size of the spacecraft, on the different shape of the spacecraft. But then if you have on board some propulsion system like thrusters, the different technologies of thrusters, you can just decide to maintain and keep your orbit and to maneuver it for just, for example, compensate the decay that you are facing in a different period of your missions. Or, for example, even the International Space Station has the chance of just maneuvering his vehicle for example, some maneuver that can be used to avoid the collision with some space debris that could damage with the impact with the space station, for example, some solar panels that they have for surviving. So if you have thrusters on board, it's easier to just being able to maneuver. Otherwise, you just need on some actuators, some sensors that can be included on board your vehicle and allow you to, for example, perform maneuvers of pointing if you have to target a specific position on the Earth. So you can change the relative position of your orbit vehicle depending on what's your interest, for example. And also here, all these sensor and actuators are piece of electronics that communicate with the onboard computer of the spacecraft. So everything can be just then connected with the technology. So don't think that I'm just talking of something that it's so completely far away from what any electronics engineer or mechanical engineer, for example, see every day. So, but I'm gonna arrive there. Then, of course, to recharge the batteries that to work, all components needs batteries, and then to recharge the batteries, every spacecraft needs solar cells that are going to be recharged directly by the sun exposure, and all the different units on board that allow to distribute the power and to interface all the different components that you have on board and allow the spacecraft to operate depending on its mission. Then depending also on the environment, you can have a lot of different temperatures or thermal conditions on board your spacecraft. So depending on the altitude on the mission, then you can understand, for example, by doing simulations, which can be the range of temperature in which your spacecraft, for example, or interplanetary vehicle should operate, and then try to compensate these temperature in different ways. For example, of course, you need sensor to monitor the onboard and external temperature, but then depending, for example, if your components can survive or not in the detected temperature range, then, for example, maybe you could need hoovers or heaters on board that allow you to keep the, for example, more sensitive components in the type of range in which you want them to work. But this is exactly something parallel to any electric components that within their data sheet or manual, they have some conditions in which they need to be kept, they need to be preserved, stored, and they need to operate. The same it's in space, but of course, given that you cannot then realize that later or go and try to solve the problem after having your satellite in orbit, this is something that it's tackled during the design and during all the analysis that you do in the project definition and preliminary phases, in order then to be sure that when your platform is reaching its environment, the operative environment in which it needs to operate, then he is ready and all the operation can be safely performed. Then, of course, for being sure that your satellite is doing what you need, and also for example, obtaining the information that you are interested in. For example, for the easier way is the Earth observation field. You have a camera on board the satellite that it's shot in pictures. So it's acquiring pictures that the users want to use for different type of applications. But so for being able to download the picture to the Earth, the spacecraft needs to have its own antennas and all the system and subsystems on board that are able to just manage the communication with the ground. And then on the ground, you need to ensure also the possibility to receive this information. And when during all the operation of the satellites, you will ensure the satellite passing over or in the visibility range of your ground station, or for example, a network of ground stations that support you or that you own, then you can downlink or uplink new commands and up and downlink the information that you want. For example, you want pictures to be that are gonna to be held to another company, or you just want some information that are telling you that everything is operating in a nominal way on board the spacecraft. And then, of course, you need a big brain. You need a big brain on board that it's allowing you to manage all the operations, or it's allowing you to just perform everything that it's gonna be done in the meantime. And so this is something that it's very, very important because you need to ensure that the onboard data handling system, it's able to understand the instructions that are sent from the ground and to operate the spacecraft remotely. So also the software that allows the big brain of the satellite to work, it shall be designed and developed accordingly to what your spacecraft needs to operate. And so it's very, very important to have all this information on, defined even before starting the algorithm development, or to write down to code, for example. And of course, then if your interest is to store information, because for example, every day you only have, depending on the ground station, that you have maybe only a few minutes in which you can downlink information, then on board you need you need to memorize and to store the information. And so let's say that all these different aspects are required then for allowing the main payload to do what it shall do. Payload is very, very one of the main words that when you work in the aerospace sector, you really focus on, because the payload is the core of the mission, is the reason, is the base of the rationale why you sent that spacecraft, why you developed that code, why you sent that space vehicle. So, for example, in the ISS, the main payload are the astronauts and all the scientific experiments that needs to be performed. But so all the environment, all the different models that the ISS is based on have been designed by keeping in mind that everything shall ensure that the astronauts needed to just survive in those environments. So, for example, Earth observation satellites, everything is designed by keeping in mind that the instrument, so for example, a camera, a radar, any instrument that, for example, needs to acquire data of the Earth, needs to be operative with specific parameters or with the specific performances that then will allow the entire spacecraft to perform the mission. So if you want to work in that, remember this word, payload. It's exactly the reason why people can give you money, or the space agency wants to fund a specific mission. Then, as I mentioned, there are different phases in a mission. usually you always start from a very, very detailed definition of what a mission shall perform and all the functions that your platform needs to ensure to just be able to perform this mission in the environment in which you decide to do. And so these are the first two phases of any space project. And depending on the agency, depending on the standard, they can have different names. But let's say that the European standards names them as phase 0 and phase A. And so you spend your time in trying to understand what can be done for fulfilling your objectives of the missions that needs to be clearly defined, and then which can be the different options in terms of hardware, in terms of operations, in terms of entire segments that you need. So what you need in space, what you need on the ground, the interaction between them. And once you are able to define these, you spend your time in this other big phase and big topic that's related to requirements definition. Requirements are all the different qualities and aspects that your mission needs to ensure. And that needs to be verified before being able even to launch your spacecraft or your vehicle or to perform your mission related to space. So it can be, for example, a very, very simple one. So your spacecraft needs to operate in a temperature range, for example, between minus 40 and plus 70. Has other that, for example, the communications between ground and space needs to be ensured. So from a very high level up to the most detailed one, because then every aspect that's linked to requirements, it's directly then linked to the definition of the main qualities of the system, and so on. And shall be verified even before then being able to start realizing and operating your system. And in parallel, then, of course, you start producing what you need, what has been designed according to requirements, and to test all your hardware, for example. Even before then arriving to the phase E, in which you effectively utilize your hardware in space, for example. So here you can see that there are a lot of phases before arriving to effectively put in orbit your spacecraft. And if you want to successfully operate and fulfill your mission, you need all the previous phases, because these have been defined from experts and years and years of experience in which they have demonstrated that by properly planning, it's a lot more successful than the mission, especially because it's so far away. And then you do not have the chance of just, for example, torquing a screw that you forgot to torque before launching your satellite. You cannot then arrive. It's space. So the different kilometers and different distances are also a limitation on this sense. And of course, then at the end of the mission, you need to consider that then your technology needs to be disposed. So for example, if that's small, if it's a very low orbit, it can be, for example, just you can ensure a re-enter in atmosphere that will just, let's say, be able to demolish everything. So without the risk of having a piece of spacecraft on your head, or for example, for bigger platforms, you can then re-orbit those in other orbits. But I will try to just, sorry if I went a bit too long, but I think that this information are really, really important then for being able to understand what's needed to arrive at this point. So I will try to see if there are some specific questions on this topic before arriving to the next one related to software and machine learning engineers. So as I mentioned, so given that it's aerospace engineer an engineering background is a very, very strong asset for just fulfill a career on that side. I'm trying to reply to Charlotte's question, that it's, can you become an aerospace engineer without a bachelor degree in any STEM field? And if so, what advice do you have for those people who do not? As I said, a master in space engineering doesn't require a STEM background. Of course, then you need to just integrate your background with some technical aspects. So there are some universities that allow you to do some integrations. If you didn't specialize in any engineering subject or STEM subject. Or then, for example, there are some other entities that allow you to work on that, but I know plenty of people that then it's not for working in aerospace, being an engineer, it's not the only career that you can fulfill. There are also a lot of other aspects. But then if you like technology, if you want to have a background on that, for example, even a coding course can allow you to just acquire that background that could be required, and then by having, for example, a master in that. Or if you just have a software background, for example, if you just learn to code those languages that are the mostly required, then you can just go and tackle that on different aspects. For example, as a data scientist working on space data, for example. I hope this was a satisfying reply to your question. Then what are some good books you have recently read? Good question. So let's say related to my professional career, I would strongly suggest a very, very short book called 1 Minute Manager. It's not directly linked to the aerospace sector, but it's a really, really interesting reading for who are also interested in a management career, for example. And let's say that even if in COVID times you could spend a lot of time, let's say you have to spend a lot of time at home, the fact that I'm working every day on technical topics didn't allow me to have too much time to be spent to other readings, technical at least. Any path for someone who takes a coding bootcamp without an engineering degree to become a space engineer? I think that I already covered that, Rodrigo, with my previous reply. But as I said, depending on the language and coding skills, but I will go deeper on that later. Then there are, of course, there is a lot of space. There is a lot of space also for people that can code and that have specific skills that are very, very useful in the aerospace sector. For Sasha, yes, so I'm trying to just go a bit faster on the next one. I will try, okay, yes, 1 Minute Manager. Okay, let's go on the next section. This is gonna be fast. So then I can eventually also share with Sasha and with who can be interested in this presentation that includes some specific information. So for example, as I said, given that you have an onboard computer and you need to manage autonomous operation, or you need to communicate, but then you need to have hardware that it's responsive, that operates what you are asking to the system. Then, for example, onboard operations of the spacecraft, software development, it's required for that. So the onboard computer needs to be, needs to run and to be managed by a specific code. And I don't know why it happened. Yes. So, for example, for the deployment of a solar sails that it's on orbit, that everything shall be managed by the onboard software that needs to be developed and coded. Then ground stations require their own software and interactions then with the hardware like antennas or with even internet. So everything that's required for that, it's based on software, and let's say it's functioning because it has the software running and managing all the ground stations operations. Then, for example, when you also have ground stations and you want to command and to interface with your system, then you need a graphical interface for being able to just understanding what's required and to just also command your ground station and to communicate specific commands to your satellite. Then you need the software for testing. So, for example, during the validation phase, you require test for you require different types of tests, and then depending on the hardware that you're using for the testing, then of course you need to be able to interface and to command also the hardware that can be for example just also visualization tool, but then, for example, for vibration testing, you need the shaker that needs to be commanded. Then you need to interface that with the specific tools that you have on your computer. Or, for example, for also testing the functioning of your spacecraft, then you have to develop a dedicated code for just simulating different in-orbit operations that are going to test the well functioning of your entire system that you have connected. And then we arrive at the onboard data processing of data that can be autonomously operated on board, and that can be, in this case, for example, processing of data that's are acquired, for example, by an instrument on board. So for remote sensing, can be a camera, it can be whatever, an antenna that is called synthetic aperture, rather, for example. And on board, your computer can understand if the picture that you shot includes some useful information that can be then optimized and directly downloaded to the ground to optimize also the downloading process without the need of just downloading the entire picture. And then, of course, if you have downloaded the entire picture, so all the data that you collected with your instrument, then on ground, usually languages like Python or other are used for extracting information to process. So all these maps that you can see have been created with masks that are just obtained by processing images and extracting from the images useful data. To be able to, for example, work with the hardware, usually when you deal with satellite, you strongly work a lot with embedded system. And for example, for that and real-time operating systems, so there can be different types of PCBs for your onboard computer, also just for routing all your components and for just managing those depending on the applications. And one of the biggest player in latest years, it's our FPGAs that are allowing to increase the autonomy of the onboard operations, for example. Then, of course, to interface all the different components of board, you are just you're just experiencing with all the different type of interfaces, so CAN, SPI, and whatever. And of course, being able to just program those and to, for example, use Unix or know and program in Java are very, very helpful for example, other types of applications, as for example, the development of the graphic user interface that you have then for handling the testing or the ground stations. And then there are a lot of different applications that can be based on, for example, internet web development, because they allow to, for example, put on internet your service or to just reach out better your users and to share with them your data and the ones that you want to sell. And of course, given all of them, it's something very, very helpful to just have a knowledge or it's helpful to get a knowledge of embedded processors and, of course, some background in electronics to understand, of course, the hardware. It can be also helpful. I will just briefly going into machine learning, and then if you have any question, we can tackle them. Related to what I have said, let's say that in latest years, AI and especially machine learning represented a very, very big change in approaching and in just designing missions, because it's allowing to increase the autonomy of all the missions, the one for the satellites, the one for the interplanetary exploration too, and to just being able to rely more and more on the sensors and on the autonomous operations of your platforms in orbit, given that they are so far away. If you can optimize the communications and the operations, this can simplify your system, or it can even, for example, cost you less money. And for example, some autonomous ABAS assistant for astronauts that can support them in all the operations outside, for example, the ISS, or even there has been a project inside the International Space Station called Spheres that started as educational experience for schools, but then it became something larger. For example, having autonomy on board. So, for example, a code that's able to just optimize your planning on board, or to just autonomously operate what you taught him. It's a lot helpful for what concern mission design, especially the interplanetary ones that you need to plan in advance, and it's let's say more difficult, or it takes longer to communicate with them. And for example, just also to just optimize onboard operations, and for example, to have some flags on or alarm that are communicated to the ground, but that are autonomously detected on board the spacecraft if anything is going wrong. Then, as I mentioned, the autonomous onboard processing of information, for example, from the pictures, are allowing you to optimize also the amount of data that you can link to the ground, because you have only a few minutes per day. Of course, the more the ground station, the more the data amount that you can load. And this is allowing you to just being able to optimize and just send, for example, the information that you already extracted on board from your pictures. And then there are a lot of platforms that are on ground and in space for the space junk or space debris monitoring, and that are just autonomously updating the list of objects that they are detecting. And they can also work for example, propagation and forecasting any possible collision or consequences on that. And then, of course, navigation systems that can also be applied not only to the space application, but also, for example, to unmanned vehicles or drones that are very, very related and useful when it comes to our space applications. So I don't know if we still have time for questions on this topic.
There is one question that I think that would be really interesting to feature. Your journey to space career in Japan, I think it's probably something that people will definitely want to know.
Yeah.
How you ended up working for a Japanese company building microsatellites. And also, I would like you to cover the question, did you use Japanese? Like, did you need to use Japanese language while working for the Japanese space company?
Okay, so let me just go quickly through this. When it comes to soft skills, or in general, to skills to work in the aerospace sector, these are some things that you learn only by practically working, and experience is a new thing. I arrived in Japan through an international organization that gave me the chance to start thinking international, and to get in touch from Italy with Japan. So they created this network, but that's why I arrived in Japan. So I just left my own country, and I started understanding that within the aerospace sector, but in general, it's not a matter of where you are, but that you just can do what you love to do. And then, of course, depending on the country, depending on the occasion that you get, it's something that you cannot only, I mean, of course, it would have been a lot nicer to just also remain in Italy, but then I wanted to experience something different that really helped me to grow a lot and to learn even more about myself, not only about my professional and qualities. So in general, not only in Japan, but in general, to be able to think international, to speak English, and to just being able to interact with the completely different people than yourself, it's something that is fundamental. Then, of course, there are a lot of different other soft skills that you can develop, you can work on, that you have, that you can discover of yourself, but that can, let's say, that can represent different aspects of what you could have, or what you could learn. But let's say that this is something that I have learned at first in my professional career and when I entered in the aerospace Japanese sector. So I started working in a completely Japanese, so in a traditional Japanese companies as Canon Electronics. And the space department, I was the first foreigner there. And before my arrival, they never spoke they always spoke Japanese, but then after the arriving of a foreigner person, everything was just slowly moved to bilingual, so both documentation and also interactions within the team. So this gave me the chance to just cooperate and interface with the colleagues. Another very helpful means was the introduction of an internal chat, so that allow and helped a lot, different level of interactions, or even speeded up the communication between all the people involved in the project. And everything was, at least with me, managed in English. And for example, during the meetings, that was done halfway around. So for example, taking notes in English on the whiteboard while they were discussing. And then in parallel, of course, I wanted to just improve my Japanese skills. So I also studied on my own Japanese for being able to just interact with my colleagues. Of course, 2 years were not enough, but this is something that have been helpful also in my approach to the company, because it demonstrated that I also accepted a completely different culture. So you need to be able and to accept compromises when you start working in a different culture and a different country, and you learn to be flexible, or at least you have to learn to be more flexible, to understand that the way in which you think, it's not 100% the correct one, but that there are a lot of different perspectives that you never even started to think about. So I was mentioning an international association that was born in Japan, called UNISA Global, but then became international. It's a university space engineering consortium of a lot of faculties that have hands-on projects in space, related to space. And so through this experience with them, I had the chance of just presenting my project, to get in touch with international people, Japanese companies. And so through one of these connections, that's how I ended up in Canon Electronics in Japan. And that gave me a very, very precious chance to just work in the Japanese aerospace sector. And I just summarized here briefly some of the main companies that you can find that are now working in the aerospace sector in Japan, just different levels. So you have bigger and older company in terms that they have been players in the aerospace sector for more years, not that they're old, and also some new startups or medium companies that there have been startups up to a few years ago, like Aerospace, Astroscale, Synspective, that just started entering in the aerospace sector with their products. But so one of the things that I think are the future also for the aerospace sector is to become more international, because then if you want to have success, you need to just consider with the big pictures. So all the players that you have at international level, and If you don't, then you just, let's say, cannot be competitive with them. If you don't speak English, then how can you deal with the international players? How can you deal with the US or even at the engineering level? Then a lot of engineers needs to also cooperate and to, I don't know, maybe sell or support the selling phase of your components. And so again, thinking international, it's something that it has been fundamental for me, and it still is fundamental for me, even in my current experience here. We have 5-6 different nationalities, even if it's Europe in the same working team, and we all work in English, given that we have project with, in this case, European Space Agency. No, I don't know any of the Wagon graduates, but hopefully I will know them soon. But this is because so I only get in touch with the Wagon lately. So I think that up to now I almost covered all your questions, and remember that the space is not the limit. Our mind and our energies and our willingness, it's the limit, or it can be just the start of a marvelous journey that can lead you whenever you want and whenever you dream about. This is for everyone, any gender, any background. It's just a matter of understanding when you want to arrive and what's needed to arrive there. And then it's just on you, a day by day work.
Cool, thank you so much, Alice. It was really very, very informative, and I think that like some topics, especially about the machine learning engineers and software engineers and some possibilities, were definitely interesting for people. What I want to add from my side is that, of course, just by learning how to code, especially web applications, you won't become a space engineer. This is something that requires much more effort and much more skills. But I would say that people going through data science bootcamp, they have more chances to end up in the aerospace engineering, because as Alice mentioned, the data processing, data science, machine learning is something which is very much needed.
Especially lately.
Of the image processing, right?
Image processing, but in general, data processing in general. It can be, for example, signal processing. It can be pictures, so Python libraries, or for example, in my experience, by learning some image processing techniques based on C, for example, on OpenCV library of Python, or during university, Astra has to use MATLAB, for example, as other language processing, language programming. Then it really depends on the applications, but there is a lot of space for data scientists, especially because a lot of agencies all over the world are pushing a lot. For example, the European Space Agency is focusing on the Copernicus program, in which there is the availability of data, of terabytes of data that are acquired by the Sentinels, for example, that is a constellations of large satellites in a low Earth orbit that are just acquiring different types of satellites, for example. But so they are giving for free this data, and they are emphasizing a lot that there is the need of being able to extract information from all these types of data, and to find a market for them. So, for example, it can be land coverage monitoring, and then you can extract data from, for example, you have a crop field, and then you can extract information and useful data that can be then given to the farmers or the producer, or who is using that, or he's cultivating that crop field, for improving, for example, the production, or for optimizing the culture. So this is just an example. I have seen that there is a question. The next step in my career, what organization do you want to work with the most? Okay, so let's say that I just started in this new company. So at the moment, I'm thinking that I want to just grow up and to consolidate my skills. Let's say that after these few years in which I have started, I understood that for sure, as a system engineer, I work more on the, let's say, technical management of all the technical aspects. It's like a project manager, but I don't manage resources. I manage more the technical aspect of, for example, the project of the design, or I cooperate with my team in which we cover the technical aspects of a bigger project, for example. But then for sure, I would go more into the management side. So I would like to become soon enough the project manager. And I mean, it can be my company, whatever. It's a matter of not, I do not have, I mean, I decided not to link my future and my dreams to a company. I want to link my dreams and my future and my career to possibilities. And so, and given that I love what I do every day, I want to just continue doing that. So I hope that I reply to your question. Yeah, computer engineering undergrad, and I was wondering, would there be many opportunities for me in the space industry? Yeah, of course. As I said, for example, depending, of course, of your skills and what you like, then, for example, there is a huge demand for embedded system engineers, FPGA developers. So also aspect of digital design, or the compromise between hardware and software that FPGA are currently giving. So this can be also very, very helpful. For example, it really depends. If you prefer one language to another, or a specific application to another, then there is space for any type of developers in the aerospace sector, as I was mentioning in my presentation. What about mechanical engineers? Do they have chances? Of course. I mean, consider that we need to develop hardware, and the hardware needs to be tested, needs to be brought in space. So I think that at least once you saw the big launch of a spacecraft, and it's a huge, let's say, load environment, and you need to test and to analyze your hardware and its applicability, and you need to ensure that it survives also to, I don't know, 10G, 100G, that it's the load that your satellite is affected by when you launch it with a launcher before reaching the orbit, for example. So there is an entire field of applications for example, structural analysis, finite element models that can't design, because you need to design what you are going to realize, what it's going to help you fulfill your mission. What about then a master or a PhD is more, it depends. A PhD usually is helping you if you are interested more in research. Or, for example, in working for an agency. Then a PhD is a strong asset for then arriving and joining a space agency like NASA has an international for a postdoc program dedicated to internationals, for example, or then even other associations, or even JAXA allows you to do a PhD within JAXA with strictly cooperation. So the more you know, the better, but that's in any case. Could you also share the name of a space consortium? Yes, so it's called UNISEC Global. And they have different activities, and you can see the website for that. Thank you very much for attending, Rodrigo. And what developer project can you recommend to build skills useful to add to your resume to get a job in the space industry? So it's not a matter of project. So as also Sasha said, and I was mentioning, at the moment there is a strong demand for embedded systems. So all the types of skills related to that, to the handling, to the programming, to the testing. Then machine learning also for data processing maybe, or mainly, and autonomous operations. So being able to deal and to program embedded systems in cooperation with machine learning. So also FPGA designer and developers, for example. This is also something very, very useful. then I think that C language, C++, Java. So depending on what you like, then you can go deeper in one of the others. For example, in my previous company, there were a lot of colleagues that were just, for example, coding for then the onboard software of the spacecraft, but then there were also others that were more with the graphical interface development for our ground stations, for being able to detect anomalies and to program something more reliable, for example. To be able to just better visualize and to simulate, even simulate some operations, or to just have an interface that were able to communicate with the hardware to test and simulate different type of functionalities that then you have in space for simulation, for being able to check your system before. I hope to have replied to all your questions.
Cool. Thank you everyone for your questions. Looks like we had a lot of people coming from some specific backgrounds and different types of questions, from how to start and how to proceed. My apologies for making it slightly over the time, but I'm sure.
Sorry.
No. I mean, that was really amazing. The content that Alice shared with us was very, very interesting, informative, and I think very helpful for those who are thinking about getting into the industry. Maybe the last question would be really nice to know how to find a job actually at those kind of agencies. Do you think the best way is to check their websites and check their, are there any some specific career fairs, or how do people usually recruited in this kind of industries? Thank you, Bernie. I think he's already suggested.
Yeah. For example, you can get in touch with him. He is representing also. So he's working in one of these entities that it's trying to fill the gaps between, let's say, aerospace careers and people that can work on that. Then, for example, association like UNICEF Global or universities organize fairs, space job fairs, for example. There is another website that you can use, that it's Careers in Space. They have a LinkedIn page, or they have a dedicated website, for example. Then platforms like LinkedIn are very, very helpful. For then researching you can just, for example, use some keywords, and then you can look for the area in which you would like to work in, geographically speaking, or the different skills that you want to exploit, for example. Then recruiters company. So some of them are also can also lead you, and I know that in Japan that it's something quite common, but also in Europe it's becoming more and more common to just relying on companies that help you and guide you and put you in touch with the industries that are looking for someone with your background. Then, for example, at university level, if you are still a student, it has been fundamental for me attending international conferences, because attending international conferences means to also go to the exhibitions. Now in COVID time, everything is online. So everything is more helpful, but there are a lot of conferences every day. So for example, if you go on Space News, that it's one of the main websites with the information, then there is a section dedicated to conferences when you can sign in. Some now are free, for example, and then usually companies go there and present their services. They go there for, let's say, commercial purposes, but then you can get in touch with them. And it has been some cases in which they were there offering also some internships, for example. Then with the agencies is a bit different, but for example, for ESA, you have the website, or if you are, for example, a student graduating, that there is a dedicated young graduated trainee program that it's open every year. And now it's still open, the one for Europe. I think it closes in March. Then connections. The more, of course, you do, the more you present, the more you know, the better and the easier it is to get in touch with people that rely on you, rely on your skill, and that can be interested in hiring you, for example. I hope to have satisfied your curiosity about this.
Yeah, that's amazing. Thank you so much for sharing all this info. That was very helpful. Maybe you mentioned about the connections. Do you think you can also share the way to contact you if someone wants to get some advice or something like that? If you want people to contact you, what is the best way to do it?
I think through LinkedIn.
Okay, guys, just search our speaker's name today in LinkedIn. I think this is the best way. And also don't forget to write down some message that you have been at this event, because I'm pretty sure you get a lot of messages every day, a lot of requests, and it's better to know whom you're getting this request from.
Yeah, and one last tips that I'm willing to share is to work on your resume, on your CV. Especially have that in English, even if it's in your own country, to show that you think international, and then to just be able to clearly quantify your achievements, or to just being able to share what you want to wield. So for each experience, a simple bullet point with what you have achieved. It's the most effective way for just sharing what you have learned, what you have done, and for also allowing, for example, a recruiter or who is evaluating your resume and cover letter to understand if you fit with the application, and then to just modify and adapt your CV depending on the application, because there are some experiences that maybe can be a stronger asset for one or another, or something that it's not related. And so just try to be competitive on that.
Cool. Thank you so much for amazing share of information that you delivered to us today, Alice. It was very cool, and I see from the chat that audience enjoyed so much. Thank you so much, everyone, for coming and staying with us until that late in Japan, until lunch time in Europe. It was really nice to have you all. And I'm going to wrap up this event. Maybe, Alice, some last words from you.
Yeah, if Sasha agrees, then I can share with her the presentation, that it's including some maybe interesting information that you can also check again after that. So I will just share with her, and then she will decide which is the best way for sharing that. And so, as I mentioned, the aerospace sector can seem so far away from us, but it's not. It's just in our daily life. And if you are passionate about it, if you want to discover something new, I think that if you want challenges, this is something that can be very, very interesting for you. I really recommend that.
Thank you so much, Alice, for motivational words. So strongly encourage people not just to follow tweets about launching another rockets, but do something solid and maybe make first steps towards the career in space. Thank you so much, everyone, for joining, and have a great evening for those based in Asian zone. Have a great afternoon for those based in the European zone, and hope to see you again at our events. Thank you so much, Alice. That was amazing.
Thank you very much to all of you. Hopefully meeting you in the space sector soon.
Let's meet you in the space. Sounds great.
Bye.
Thank you so much. Bye.